Hello all. So far I see Abby, Felicia, and Gio. I'll start off by welcoming you to our online lecture. I see more people joining in. As you're joining in, I'm going to mute you. So I'm going to mute all. But I will allow, but you can always unmute yourself. I'm just going to start off muting you just in case you didn't know how to. I started muting you because sometimes we're unaware that our microphone's on and you can hear everything. You can hear like you moving your laptop back and forth or the birds outside or something. So I will mute you all. Okay. Just as before we start, I have gotten emails from letting us know that during Zoom lectures, it might be people who show up uninvitedly. So that's why our Zoom lecture has a code that made you enter a password, because we've heard about people bombing in Zoom lectures and saying and doing inappropriate things, people who are not even part of the school, not in the class. But I'm very happy to see you all. I see most of you are in the class. Pardon, what'd you say, Joshua?
I said I'm so happy to be here too.
Yeah, luckily we're not like one of those people who like say rude things on the class. Like we're just here to bring awareness.
Yeah.
That's good.
Yeah, so we could get on. Did you do the homework? I didn't do my homework today. I'm really sorry.
That's fine. All of your homework is open until the remainder of the semester.
Already
Oh.
finished.
Yeah. Now when I go onto Pearson, sometimes when I click on assignments, it takes a while for all of the homework to load. So I have to give like a good like 10 minutes, not 10 minutes, like 10 seconds, and then all the homework shows up. But it's been slow. But I think a lot of people are switching on to Pearson online stuff because of of what's going on right now. So it's causing it to move a bit slow.
Dude, no. What's that behind you?
Which one?
Man,
This one?
the team? No. Miss. She has like a wreath behind her. Love it.
Oh, it's a painting.
Oh, it's a painting.
It's a painting and a decoration. It's not like a filter.
You're lying. Okay, I'm sorry to just, no, my bad.
Okay, so let's go ahead and continue. So as long as people chime in, that's good. This lecture is being recorded, so you can always go on Canvas and upload and see what we covered, so in case you know someone who wasn't able to join us. So let's go ahead and begin. I'm going to share my screen, and just again, I'm going to mute everyone.
Okay.
All of your notes are posted, so it's like an outline of them.
Hey, I'm sorry, Felicia, can I have to ask a question? Felicia, you didn't though. I know I asked you for the homework, and she told me, like, I was asking her for the homework because I couldn't figure it out myself. She told me she was not gonna give it to me. She's not about that life. She like respects you, but and after the meeting, can you just like get me the answers?
After the meeting, you guys can break out into separate Zoom meetings, and you guys can also make Zoom meetings within yourself. So you can do your homework together, you can do your quizzes together, you can work together for sure.
Oh, yes, we're doing that.
All right. Okay, so let's go ahead and continue with today's lecture. So I'm going to go ahead and share my screen. All right. So we are going over 3.5 and 3.6 today. 3.5 is operations with factorials. Now, from our last class meeting, we introduced factorials, and you guys seem pretty okay with the content. So factorials, let's start off with that little recall box. Recall factorials, let n be a positive integer. The expression n exclamation point, we read it as n factorial, is defined as, oh, I didn't close my parentheses. Is defined as, so if we have a number with exclamation point, we're going to multiply that number, starting with that number, and multiply by every number going down 1 until we reach 1. So just to remind ourselves, 0 factorial is 1 because it goes behind that thought of how many ways can you arrange the number 0. If there's only 0 things, then that's only one way you can arrange them. An example of how factorial looks like. So if we have 4 factorial, that means 4 times 3 times 2 times 1, right? If we were to have 5 factorial, then that would be 5 times 4 times 3 times 2 times 1. So that's a factorial. Now, if you recall in our last lecture, we learned how in your calculator, there's a button so you can do factorials in one shot, right? So you're not stuck there multiplying 5 times 4 times 3 times 2 times 1. Okay, now we're going to do a bit more work with factorials moving forward. We can also work with factorials, meaning we can divide, multiply, and divide. We're just really working with big values. Because remember, a factorial is a really big number in disguise. Because, for example, 5 factorial.
Okay, I'm so sorry to interrupt again, but honestly,
No, good question.
It's just this, like, all these numbers, it's physical and mental abuse to my head. Honestly, like, it's like Chinese to me and my brother. We're not the best at math, and it gives me the most anxiety I have ever had in my entire life. It's abusive. It's literally abusive. It's so much.
I don't think it's much work. It's just multiplying. It's just a different way of seeing multiplication.
5. Yeah. So like if it's a 5, all right. So 6 factorial.
I'm sorry. Abby looks like she's getting real annoyed with us. Like I felt like there are no dumb questions here. Abby, I saw you like rolling your eyes at me. We could leave.
You know what? There are no dumb questions at all, but I will go ahead and continue with you. Is he gone? Oh.
Yeah, I think they're gone.
Were they even in our class?
I don't even know.
I don't even know. I was going to check the roster right, and I was going to tell them, you know what? I'll talk to you. I'll give you a lecture afterwards. Let's just continue. Because no one was ever that vocal in our class ever. I mean, not that it's a bad thing. We have a quiet set of people, and that's okay. It's usually morning classes that are like that. And I was going to check my web advisor. Now I'm curious. Give me a second. Entertain me while I check my web advisor. Faculty. Guys, I think we were Zoom bombed. Yep, we were Zoom bombed. So what that means is someone joined our Zoom. It's gonna be funny. But
like a photo bomb. And then I can't see nothing, but can you guys see me? I don't know.
Let's see. I can't really see much people because I have everyone just out. But it's okay. We don't need to see you. If you have a question, you can just unmute your mic, and that will be helpful. All right. So let's continue with our lecture. I'm going to mute you all. But if you have a question, you can chime in. Just unmute yourself. Okay. So let me go back to screen lecture to share content. All right. Can you guys see my screen? Yeah. Okay, good. Let's continue with my lecture. So we're in 3.5. 3.5. Where is it? PDF, here you go. All right, so factorials are just a shorter way of writing multiplication. So 5 times 4 times 3 times 2 times 1 is 5 exclamation point, and the same as 120. Okay, so we said we can also work with factorials. We can multiply and divide. We're just working essentially with really big numbers. So even though it's an exclamation point, we know it's a really big number in disguise. So to help us, keep in mind let's remember this, that a number divided by number is 1. So we know, for example, that something like 4 divided by 4 is 1, right? 4 over 4 is 1. So it would be the same that 4 factorial divided by 4 factorial is 1. So if I have a number divided by itself, regardless if it's a number with an exclamation point or a number with an exclamation point, something over itself is 1. So to multiply, now for these, you can totally use your calculator. You don't have to write the multiplication out. But if you want to, we can. So 2 factorial times 2 factorial is 2 times 1 times 2 times 1, right? Which is just 2 times 2, which is 4. All right, now we have 4 factorial times 4 factorial. So that means 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. And you can multiply everything out, or you can find out what 4 factorial is. You can punch into your calculator. So if you forgot how to use your calculator, just make sure to ask me after class and I'll be happy to walk you through. So 4 factorial is 24. So we have 24 times 24, which gives us 576. 1 times 8 factorial, well, 1 factorial is just 1. 8 factorial, maybe we can use our calculator for that. So 1 factorial is 1. Let me use my calculator if I want an 8 factorial is. 8 factorial is 40320. So 1 times 40320 is just 40,320. All right, any questions about our first set of examples that we multiply? Alrighty, let's go ahead and continue with our division. So we can also divide factorials. Now for these, you can punch them into your calculator and just see what you get in the end, but we can also play with it a bit more. So remember, if I have something like 5 factorial and make 1, right? I can cancel them. So let's go ahead and work through the next set of problems. So I have 15 factorial divided by 14 factorial. Okay, let's be careful. Let's be creative. So 15 factorial is 15 times 14 times, well, I'm not going to write anymore. I'm going to write just an exclamation point. Because in the bottom, I have 14 factorial. Now we cleverly, very cleverly, we purposely stopped at 14 factorial so that we can cancel or cross it off. So now I have 14 factorial divided by 14 factorial, that's gone. So my answer is just 15. So you can purposely stop at the number. So just to think ahead of our next problem, I have 4 factorial on the top and on the bottom I have 7 factorial. So as I'm breaking down and rewriting 7, I'm going to purposely stop at 4, right? So I can cancel it off. All right, so let's go ahead and work with the next one. So I have 4 factorial on the top. On the bottom, I have 7 times 6 times 5 times 4, and I won't continue with times 3 times 2 times 1. I'll purposely stop at 4. So I can divide these to make 1. So then I'm left with 1 over 7 times 6 times 5. And then I can use my calculator and multiply that. 7 times 6 times 5, you get 210. And this would be our answer. Okay, so I'm gonna draw a line because I'm kind of running out of space here, just so you don't mix up your work. I would hate to confuse you with all the writing. All right. Next problem. 9 factorial divided by 4 factorial over 10 factorial. Okay, so I'm looking at this 10. And the top, I have a 9 factorial. So I want to stop that 10 at 9 factorial, right? So I can cancel it out. Okay, if I do so, I have 9 factorial for my numerator divided by 4 factorial times 10 times 9 factorial. So we're breaking down, we're rewriting the 10 as multiplication, but we're stopping at 9. So we can boop, boop, cancel that one off. All right. So the numerator, I have 1. There's nothing more in the numerator, so we just have a 1. And 4 factorial, let's figure that out. 4 times 3 times 2 times 1. That's 24. But don't forget, we still have that 10 in the bottom. So we have 24 times 10, 240. Any questions so far?
So for C, how you got 4? So we're multiplying by 4, 3, 2, and 1, and that's how we got 24.
Yes. Now you can actually multiply out 4 times 3 times 2 times 1. Or you can use your calculator. Your calculator has a button where you can just do factorials with one click of a button. So it might be less buttons for you to push in. And if you're unsure, you can take a look at your calculator. You might have a button that looks something like an X with an exclamation point. And if you don't, then it's hidden. And I can help you find it after we go over the lecture.
Okay, thank you.
Yeah, no problem. All right, let's continue. So I'm going to do all these examples. Usually this is where I would tell you, okay, you go ahead and try them. But I know we work at different speeds. I for sure know I would be the slowest one. I always am very careful with my math because I always make the silliest of mistakes. But I'll just do them all with you. You can always practice these on your homework because this is what your homework will look like. All right. So I'm trying to cancel off the biggest one or the smallest of the biggest one. So here I have 8 factorial. I want to cancel it off with that 5 factorial, right? So I'm going to stop 8 at 5. Okay, so let's go ahead and write these numbers. So I have 3 factorial times 8 times 7 times 6 times 5 over 5 factorial. Ooh, 5 factorial. And we did this so we can cancel the 5 factorials. So what are we left with? We're left with 3 factorial times 8 times 7 times 6 all over. Well, on the denominator, we don't have anything, so we have a 1. All right, 3 factorial is 3 times 2 times 1, so it's 6. So we really have 6 times 8 times 7 times 6. So let's multiply that out. I'm totally using a calculator here. So 6 times 8 times 7 times 6. You get 2016 all over 1. So it's just 2016. Let's go ahead and box your answer. Question? Okay, let's continue. So here at problem E, amongst my biggest numbers in the top and bottom, I see 9 and 5. So I want to break down the 9 and I want to stop at 5 factorial so I can cancel it with the bottom one. Okay, let's do that. So we have 4 factorial, or you can cancel the 4 with the 5, doesn't matter. 4 factorial times 9 times 8 times 7 times 6 times 5 factorial over 5 factorial. And that way we can cancel those out. Now some of you are thinking, hey, why couldn't I cancel the 4 instead? You could have. You would still get the same answer. All right, moving forward. So we're left with 4 factorial. 4 factorial is 4 times 3 times 2 times 1. And that gives us 24. So I have 24 for 4 factorial times 9 times 8 times 7 all over 1. Now let's multiply that out. Times 9 times 8 times 7 times 24. We get 12,096.
I think you missed the 6.
Oh, I did? Let me see. I totally did. So that's not our answer. Thank you. So 24 times 9 times 8 times 7 times 6. Thank you for catching that. So our correct answer is 72,576. All right, one more, last one for this section. So I have 14 factorial divided by 11 factorial and 3 factorial. Okay, so the ones that catch my eye are that 14 and 11 factorial. Maybe I can cancel those out, right? All right, so let's go ahead and work this out. So I have 14, I will write down as 14 times 13 times 12, and I'm purposely stopping with 11, I'm sorry, and writing a factorial to let us know that it continues on to times 10, times 9, times 8, all the way to 1. And the bottom, I have 11 factorial and 3 factorial. My 11 factorials divide to make 1. And so we are left with 14 times 13 times 12 all over 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. And 14 times 13. Oh, well, let's just write it down. 14 times 13 times 12. Now, we haven't really seen a case like this, but just like when we reduce fractions, you want to simplify as much as you can. So I see this 6 and this 12 can be factored a bit more, right? 6 goes into itself once, and 12 goes into 6. 6 goes into 12 twice. So you can break it down a bit more, right? So our final answer would be 14 times 13 times 2. On the bottom, I have 1. That way you can simplify a fraction before you multiply everything out. So 14 times 13 times 12. Times 2, not 12. Times 2 is 364. So that would be our answer for F. Any questions about this section 3.5, working with factorials? Okay, let's continue on with our next section, 3.6. 3.6 scientific notation. All right, so make sure your mics are muted until you have a question, because otherwise we hear every noise. So we hear you moving your chair, your desk, your laptop. All right, 3.6, definition. A number written as a product of a number x where x is between 1 and 10, and the power of 10 is said to be written in scientific notation. That's a number that is written in scientific notation when it's written in the form of x times 10 raised to a power. Okay, so we're going to use scientific notation because we use this when we have really small or really big numbers. So this is really a shorthand for very large or small set of numbers. For example, what if we did like 15 factorial? That would be a really big number. If you punch in 15 factorial into your calculator, you're not going to get the whole number. It's way too big to fit on your screen. So for example, I see 1.37674368 E12. That's what my calculator tells me. Why? Because the number is too big. So this part right here, that E12, is scientific notation. But your calculator doesn't write it as 10 to the 12th power. It writes E12. So this section is really to prepare you for what you'll see in your calculator. When you go on to statistics, there will be probabilities that are too small, so you'll have a really small number, or you might be working with a number that's too big and your screen will not fit that number. Also, if it's too small, all the zeros in front of it will not fit in the calculator. So we will use scientific notation because that's what our calculator might tell us. So if we can read our calculator when we move forward, it would be really helpful. All right, so here are your steps to converting from decimal notation to scientific notation. And I'll come back to our 15 factorial once we see how to work this out. Step 1, count the number n of decimal places that the decimal point must be moved in order to arrive at the number x. And x has to be 1 between 1 and 10. So this number x has to be numbers like 1 all the way through 9. And you can work with any decimal in between, but it cannot be bigger than 9, so I can have 10 point something. That's not how it works. We have a set of rules we must follow. Step 2, if the original number is greater than or equal to 1, the scientific notation is x raised to the times 10 raised to the n power. If the original number is between 0 and 1, the scientific notation is x raised times 10 raised to the negative n power. So this would be a really small number. And this would be a really large number. So let's see how we work this out in scientific notation. Let's do example 1. Write 5,283 in scientific notation. Okay, so to begin, I need to put a decimal point between the 5 and the 2. Okay, now each decimal point I want to keep track of from there. So I have 3 decimal points. So I would write this as 5.283 times 10. And because I have 3 decimal points that I must work with, I have 1, 2, 3. This would be to the 3rd power. Okay, now this is our answer. To explain this a bit more, it's easier to go from scientific notation to the number than taking the number to scientific notation. So if we want to rewrite this 5.283 times 10 to the 3rd power, if I want to rewrite a number without using scientific notation, because it's a plus 3, this means I will move 3 to the right, our decimal place. So I take my decimal place and move to the right 3. 1, 2, 3. So my number is 5,283. And that's the same number we started off with, right? So this is a way you can take a big number and rewrite it to use less writing. Now these numbers are not too big, so maybe it might seem unnecessary, but in the future you will see numbers are too big that we might want to rewrite in scientific notation. Example 2. So here we have a really small number. Write 0.054 in scientific notation. Okay, we want to have the decimal between the 5 and the 4 because my number needs to be between 1 and 10. And we see that we move our decimal point 2 spots. So we have 5.4. Because it's a really small number, it would be -2. This would be our answer. Now, if you're ever unsure, you can always check it. I have 5.4, and I want to move it 2 spaces to the left because it's negative. All right, so I have 1, 2. This is my new decimal. And wherever we had a empty spot, we put zeros. So this will be the same thing as 0.054. And that's what we have, what we started off with. So it's a good way to check your work. But our answer is what is boxed. All right, example 3. So we want to write 2.3 times 10 to the 3rd power in decimal notation. I forgot to write that down, notation. That's for your problem ones. All right, so because we have that 3 that's positive, I'm going to move it to the right 3. So we're going to move the decimal to the right three spots. Okay, so our answer would be 2.3. I'm going to move it to the right 3. So we go 1, 2, 3. This is my new decimal. And every empty spot, I'll put zeros. So my final answer would be 2300, 2,300. So that's how we go from scientific notation to decimal notation. All right, next one. So same idea, but be careful with those negatives. So because I have a -5, this means I will move 5 decimal points to the left, just like a number line. We have a number line, right? And I have 0. The left I have minus, to the right I have positive. So because it's a minus, I must move to the left. So I have 4.57. I'm going to take my decimal and I'm going to move it to the left 5 spaces. So I have 1, 2, 3, 4, 5. All right, so my answer would be 0.0000457. Your answer. So that's how we go between decimal to scientific notation and scientific to decimal notation. Now, one quick note where it says right here that has to be between 1 and 10, it's referring to this number. You don't want a number that's bigger than 10, and that's all it's saying. And you don't want a number that's smaller than 1, like 0.02. You want to make sure it starts with like a 1, a 2, 3, 4, 5, 6, 7, 8, or 9. That's what that's referring to. All right. Okay, we can also multiply and divide scientific notation. So laws of exponents. We have 2 laws of exponents we're going to rely on. The first one is the product rule. And it says if I have a raised to the m power times a raised to the n power, I can go ahead and add the exponents. That's only if they have the same base. So I have a raised to the m plus n. Next, we have quotient rule. A raised to the m power divided by a raised to the n power. If we're dividing, then we go ahead and we subtract your exponents. That's if they have the same base. So that would be a raised to the m minus n. And this is saving us trouble of actually multiplying out the exponent and evaluating it. We can go ahead and just do a shortcut in a sense. Okay, so thus to multiply and divide scientific notation, we continue to multiply and divide as usual. Then we work with the 10 base, that 10 to some n power separately. We will have to rely on the laws of exponents written above. So before we box a solution, we must make sure that our result fits the definition of x being between 1 and 10. All right, example 5. So you do this in 2 parts. We first have to multiply your number that doesn't have the 10, and then we go back and multiply the number with the 10. So we'll do this in 2 parts. So we have 3 times 2.5. Let's multiply that out. 3 times 2.5. We get 7.5. Cool. Now I need to work with those 10s with the exponents. So I have 10 to the 2nd power times 10 to the 5th power. Now, according to my laws of exponents, if I have the same base, I can just add the exponents. So this is 2 plus 5. So this is 10 to the 7th power. So my answer will be 7.5 times 10 to the 7th power. That's not bad, right? We just multiply our numbers without the 10 and then our numbers with the base of 10 separately. So we're going to do the same thing when we divide and multiply. Let's do example 6. let's do these together. So let's go ahead and multiply our numbers without the 10. So 4 times 6, 4 times 6, we get 24. And that's going to be a problem, right? Because this number is not between 1 and 9. So we're going to change it to 2.4. So we'll do that at the end. But keep that in mind. All right, now we have to multiply these 10 bases. So I have 10 to the negative 2 power times 10 to the 8th power. We add the exponents, so I have negative 2 plus 8. So this gives us 10. Negative 2 plus 8 is 6. So our answer is 24 times 10 to the 6th power. But we need to change this 24 because it's not between 1 and 9, right? So I need to move my decimal over 1. So my answer can be 2.4, but now I have to make up with it with my exponent. So I have 10 because I moved it, because I will want to move it back 1. So from here back this way, I will have to add 1 to my exponent. So that would be a 7. That would be our answer, 2.4 times 10 to the 7th. All right, let's do B. So same idea, I multiply my numbers without the exponents. So 8 times 3.5, that gives us 28. And my numbers with the exponents, my 10s. So I have 10 to the negative 4 times 10 to the negative 2. So I have 10, negative 4 plus negative 2, we get 10 to the negative 6. Let's put it all together. So I have 28 times 10 to the negative 6. Same problem, right? So I need to change it over to 2.8. So my answer will be 2.8 times 10. But I need to make up for it with negative 6. Now, we want to move that 2.8 to a 28. So because we're moving it to the right one, we're going to have to add 1. So that will be negative 5. Negative 6 plus 1 is negative 5. Okay, next set of problems. We multiply 3.2 and 4.8. 3.2 times 4.8. 15.36. And then I must multiply 10.3, 10 to negative 3 times 10 to negative 4. 10 to negative 3 times 10 to negative 4. We get 10 to negative 7. Let's put it all together. So my answer is 15.36. Ooh, I was going to get 15.36 times 10 to negative 7. Again, we're going to want to move 1 over. So essentially, to make this our new decimal, so essentially we're going to move 1 to the right. So we're going to have to add 1. My final answer will be 1.536 times 10 to the negative 6. Okay, now to divide, same thing. And I'll do maybe just the first example. So I want to divide my numbers without my 10. So I have 6 divided by 2. You can use your calculator, you can use your brain. That's 3. I don't know why I couldn't do 3 in my brain. Okay, so I have 3. And then here, I'm going to work with my exponents. So because I'm dividing, I'll subtract. So 6 minus 2 gives us 4. So this gives us 10 to the negative 4th power. So my answer will be 3 and 10 to negative 4. So I have 3.0 times 10 to the negative 4. I'm sorry, that's just 4, not negative 4. 6 minus 2 is 4, not negative 4. All right, let's do one more. So I'm going to divide 2.4 divided by 3. 2.4 divided by 3, we get 0.8. And then I'll work with my exponents. So I have 4 minus -2. So remember, you always add the opposite so that we get 6. So we get 10 to the 6th power. Let's put this all together. My answer would be 0.8 times 10 to the 6th power. All right, that's 3.6. Scientific notation. Now your homework, I was looking through your homework and they don't ask for a lot of the work that I made you just learn. But it's good to know, it's good to see. You'll see this again in biology for sure in your science courses, because you use scientific notation a lot when you have too big of a number, too small of a number. Now, what your calculator, what my math lab homework is going to make you do, this is what you'll see. You'll see a problem like this. So 5.582851 e to the 7. So you're supposed to treat this e as a 10 and the number after it as your exponent. So your answer will be 5.582851, just like you see above. And you're supposed to change the ending to times 10 to whatever numbers after that as an exponent. So in this case, 10 to the 7th power. And that's all your homework will be asking for. So this one's a really simple homework problem. I think the purpose of this is just to get you ready for what you'll see in your calculator. So now that we are aware with scientific notation, when you get a really big number, going back to our first part, to 15 factorial, when you see that e to the 12th power, it means it's a really big number. So we have 1.37674368 times 10 to the 12th power. So we're going to move this over 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And whatever you have empty spaces, you put zeros. So our number is 1376443680000. Now we don't know if those numbers really are zeros, but it gets us an idea of how big the number is. So it's a really big number, right? It's to the billions, 137 billion. All right, so let's go back to Zoom. All right, so that was today's lecture. I'll do our lectures like this to where I have like some skeleton of it, and that way you can just follow the examples and it's less writing for you. I will post my written PDF up on Canvas. I will also post this Zoom lecture on Canvas. You can go ahead and if some part seems funny and you want to review it on your own, that's fine. You don't have to watch the whole thing if you don't need to. You can just skip to where you need to. It doesn't monitor anyway what you do with it. So you can use it at any point of the lecture that you like. Are there any questions for me?
No, thank you.
No questions? Thank you, Ruben, for your comment. For saying no, thank you.
Can you guys see me? No, because I don't know if my thing's working.
All right.
Are you guys on computers? I'm on my phone.
I'm on my iPad because my computer doesn't let me write on it, so I just use my iPad. That works out.
I use my computer. Okay, thank you. I just want to make sure.
But yeah, you can use your phone. Maybe what you did is when you first signed into Zoom, you didn't allow it to enable video.
Oh, probably.
Maybe that's what happened. Yeah, you can play around with it. I know I'm very new to Zoom, so it just feels really weird to me. I'm always stuck searching, Googling, YouTubing what to do with it. But for sure, I know it's recording. So it's recording, and you will have this posted in case you want to see this again. Now, I made changes to your schedule, and it's uploaded onto your module. I took some things out, but it's just made so that we can go through the main content for the remainder of our week. So we're on week 12, and we go up to 18 weeks. So we have 6 more weeks of instruction. I made it so that we'll have a test after every exam, after every week. So just to make sure you're keeping up with the material, maybe you can join us just to make sure you learned it at some point on your own. The quizzes will be they're not going to be too hard or too lengthy. They're just for you to try. You have unlimited tries, and your best score is what will be recorded on the gradebook. And you'll have until the end of the semester to complete them. So I know working from home, some of you might have to work more because of what's going on. Some of you might not have the ideal downtime. You might only work at nights or mornings because of what's going on in your house. So I'm being very lenient about that. So all of your quizzes will be due at the end of the semester. So you have until May 21st to complete them, along with your homework. So all of your homework is not due until May 21st. All right. And if you look at the schedule, I have a test planned for next week, and you'll have a whole week to complete it so that you can do it at your own pace. All right. Okay, so if you have any questions, you can always email me. I'll open up a discussion board with general questions in case you want to post a question to everyone. And that's it. All right, have a nice weekend. I'll see you on Tuesday.
You too. Thank you.
Bye. So nice to see you all. Stay safe, stay home, wash your hands. If you go outside, leave your shoes outside. Do all those extra things that you've heard of. Do them all just to be extra safe. All right, bye.
Sounds good.
Have a nice
Bye.
weekend. Bye.